Hello, my name is Enrique Baqueiro, and today I'm going to do a tutorial for problem 12.31. We can start by reading the question. There is no energy stored in the circuit, shown below, at the time the switch is open. Derive the integral differential equations that govern the behavior of the node voltage V1 and V2. Then part B says show that V2S is equal to the following equation. Alright, so we can start by doing part A. Right? So we're going to apply Kirchhoff's current law at node 1, which is going to be this one, to calculate the integral differential equations that provide the nodal voltage at V1. So we're going to start first with the inductor formula. So it's going to be, this one's a 1 from 0 to t of V1 dt plus the current that goes over the resistor, V1 minus V2, and then the current entering, so it's going to be IG. Therefore, that right there is going to be our first equation at node 1. Where node 1 is this one right here. Notice that only the resistance right here, the inductor, and well, the current entering applied to it, not the capacitor. For the capacitor, we're going to use another node right here too. So for this one, same thing, we're going to apply Kirchhoff's law. And for this one, it's going to be such as this. Where this one's going to be the opposite voltage, right? Because we're going to be going the other way. Is equal to 0. And this one's our second integral differential equation. Alright? Again, notice where the first one corresponds to node 1 and the second one corresponds to node 2, respectively. Alright, so now we're going to do the next part B. Let me use this color just so that we can tell the difference. Is it legible? Yes, it is legible. Alright, so for part B, we're going to essentially transform everything to S domain. So we can start with the first equation. So I'm going to make this V V1S divided by SL plus same thing V1 of S minus V2 of S divided by R, right, is equal to IG with respect to S. So now we're going to move everything around essentially by multiplying the denominator to the other components of the equation, right? So it's going to be V1 S, so I multiplied times R for this one, plus I'm going to do SL times V1 of S minus V2 of S, right? So they both have like the same denominator, and then you pass the denominator to the other side. So I'm just going to skip that step real quick since it's relatively simple. But yeah, you just, for example, on this one, you multiply times SL, and on this one you multiply times RL, right? So then your bottom's going to be SRL, and then you can multiply both sides by SRL, and that's how you get to the second equation right here. So then we keep on going. So we're going to separate the voltages, because ideally that will make it a lot easier to solve it. So plus SL minus, make IG here, which is equal to my SL V2S. Alright, so now we're going to have this equation. V2S is equal to, again, divide everything by SL, So this is going to be R plus SL divided by SL times V of S minus R of IG corresponding to S. Right, so that's our first equation right there. And now we're going to look at the other equation that we created previously and again make it into, I'm going to put one right here actually, and then make it into an S domain equation. So the previous equation was like V2, the difference of V2 minus V1. We're making it correspond to the S domain, divided by R plus CS C V2 of S is equal to 0. Again, isolate variables. So 1 over R plus S of C of V2 of S, and then pass this over like so. Right? And now this time what we're going to do is solve this specific equation to V1. And I'm going to explain real quick. Just let me finish this. I'm going to explain why we're doing it like this. Alright? So this is how you get your second equation. Like that. Right? So now what we have is essentially two equations. We have the first one right here and the second one right here. So what we're going to do right now is we're going to plug in equation 2 into equation 1 to solve for V2. Right? So, because remember, this is all part of this. Like, these two equations essentially correspond to the whole circuit, so they have to be implemented together. So now we're going to do V2 of S is equal to R plus SL divided by SL times, multiply the R in equation 2, so 1 plus R S C, excuse me, this was supposed to be a C, of V2 of S, yeah, this was supposed to be a C, alright, V2 of S minus R of IG of S. Okay, so now we keep on going. We solve for isolate the variables once again to move everything over and make it easier for us in the long run. 1 plus SRC of VS or V2S minus V2S. Right? So now once again we're going to isolate variables. This is going to get slightly nasty, but that is okay because we can handle it. So V2 of S, here we go, times essentially this massive, it's going to be this times this minus 1, right? So what I'm going to do is I'm going to make this component right here. Let me get another color so you guys can see what I'm pointing at. I'm going to get, oh, this is not a good one. I'm going to get essentially this component right here and just make it into like one, just one simple, well, not simple, but one equation. So here we go. So once you multiply everything out, you would get essentially this massive thing, squared RLC, right? And then this entire thing divided by SL minus 1, right? Okay, so then we have that, and then what we're going to do is we're going to multiply both sides by SL, so it's going to be SLR IG of S is equal to V2S R plus SL plus SR squared C plus S squared RLC minus SL. Right? So then you have to remember that the previous, or what it's asking for us, is to find what V2 is equal to. So that's what we're going to do. We're going to set everything equal to V2 corresponding to S, which is SLRIGS divided by R plus SR squared. Again, put common components together. RLC. Yeah, that should be correct. Alright. So then we keep on moving, we keep on simplifying, because remember you want to get the S squared on the bottom by itself. So what I'm going to do is I'm going to divide the entire, like the numerator and the denominator by essentially RL. So I'm going to divide by RL. So I'm going to get SIGS on the top divided by S squared C plus SRC divided by L plus 1 over L, where this is equal to SIGS, take out the C, S squared plus SR divided by L plus 1 over LC. And that is what it was asking us to show, that exact same equation. So remember, you do node analysis in the S domain, and then for the second equation, you solve for V1, and you plug it into your first equation, and essentially just follow all the way through, and then keep on simplifying, and make sure that you have everything is equal to V2, since that is what it was asking for. Alright, so this is my tutorial for 12.31. I hope it helped, and good luck.